Okay, guys, so before we talked about the idea of functions and what are functions and what aren't functions, so we're going to dig deeper into the idea of functions by looking at something called function notation. And function notation is when we write f of x to mean the values whose input is x. So now we are going to be defining what we're going to be putting in place of x. And the way we do this is using function notation. So instead of having y, we are going to say f of x, which means we are defining what the x values are that we're plugging in. Now, when we look at that, there are two types of variables that we see. We have an independent variable and a dependent variable. And typically, the independent variable is x. However, the independent variable is a variable which is free to assume different values independently of other variables. So what does that mean? That means that x could be anything we want it to be. And we're going to see some examples of that in a second. Most of what we're going to do in this class will only involve one independent variable, but realize that it's possible to have more than one independent variable. Like it says, we're going to deal mostly with one, but there will be times in which there could be more than one. Typically, let's look at dependent variables. Typically, the dependent variable is y. However, the dependent variable is the variable which is determined based on the value of the independent variables. So because I am plugging in for x, that means y is dependent on what x is. I cannot really define, I'm defining what y is based on what my x value is. So let's look at some here. What I have f of x equaling x squared minus 3x plus 7 over 4x plus 5. And I want to find each value of the function. So when I look here, I am defining x to be 7. So what that means is I'm putting 7 in for x. So I'm doing 7 squared minus 3 times 7 plus 7. All over 4 times 7 plus 5. So I get 49 minus 21 plus 7 over 28 plus 5. So I get 33 in the denominator, and then I get, looks like I get 35 over 33. Okay, so I substituted 7 in for x and then just simplified. So now it's defined into something else. Like I'm saying that x is 2x. What am I doing? I am taking 2x and I'm squaring it. And I'm putting 2x in place of x right here plus 7 over 4 times 2x plus 5. So what do I get? I get 8x plus 5. I get 4x squared minus 6x plus 7. That's all we have to do there. Let's look at one in which I'm substituting an expression. Like I'm substituting 2x plus 3 in place of x. So I'm squaring 2x plus 3. So I'm putting 2x plus 3 in place of x. I'm squaring it minus 3 times 2x plus 3 plus 7 all over 4 times 2x plus 3 plus 5. So I'm squaring this quantity. So I end up, when I square this, I end up with 4x squared plus 12x plus 9. There should be a plus 3 there. Minus 6x minus 9 plus 7. All over 8x plus 12 plus 5. So what I end up with is I end up with 8x plus 17. Then I have 4x squared plus 6x plus 7. So that's how I do this. Now you guys have examples 14, 15, 16 in the notes. Try to do those. And we're going to talk about those on Thursday. So let us look at something else that I'm just going to add. You guys can do this on the back of the notes. And what we're looking at is something called implied domain. So we know a function we've we've learned how to substitute values, but sometimes what's going to happen is I'm going to substitute a value into an expression or an equation, it's not going to work. So what happens is, because the domain deals with the x values that I'm plugging in, um, what happens is sometimes they don't work. And what we want to find is we want to find the set of all real numbers for which an expression is defined. So I'm going to deal a lot more with this on Thursday, but there's two types of functions I want to have you guys kind of take some notes on, and we're going to talk more about tomorrow about why this is the case. And one of them is called a square root function. And we're going to deal a whole bunch with these this year. And I want to figure out what the domain is. So what do I have to do? I have to set whatever's underneath the square root equal to 0. Okay? So in this case, I'm going to set x plus 3 equal to 0. And then what is it? So I'm going to solve for x. So I got x equals negative 3. Now I plug negative 3 into this. I get the square root of negative 3 plus 3, which is the square root of 0. So it does exist there. But what's going to happen is there's going to be values that don't exist. Now, in order to determine what those values are, I'm going to choose an x value on either side of the solution and plug it in. So negative 3 was a solution here. So like I'm going to plug in negative 4, and I'm going to plug in negative 2 to see which ones exist. So I know that negative 3 is true. Okay? Now I'm going to plug in negative 4 into this. So I get negative 4 plus 3, which is the square root of negative 1. Now, is that true? No, that's not a real number, so I know that does not exist there. Now, if I plug in negative 2, I know negative 2 plus 3 gets me the square root of 1. Is that a real number? Yes. So what happens is anything this way will make it true. So what do I know about all my x values? Is that all my x values are greater than or equal to negative 3. And I'm going to show you guys tomorrow about why this is a case. But just know these steps, and we're going to deal with this more specifically tomorrow. So now let's look here. I got a rational function. I have f of x equals 1 over x plus 3. So this is a rational function. What you guys will find is that rational functions go like this. So what happens is there's an imaginary line that exists, and it's an imaginary line, and we're going to look more at this tomorrow, that's called an asymptote that exists between these two branches. Okay? So in order to find out where that asymptote is, I'm going to set the denominator equal to 0 and solve for x. So I get x equals negative 3. So what happens is that anything but this value is a solution. So what I would say is it's all reals except negative 3. X equals negative 3 is the domain. We're going to deal with this a lot tomorrow in our 90-minute period. So I'm excited about that. I'll see you guys on Thursday. Have a good evening.